In this video, we're going to be talking about section 2.1, which is on quadratic functions. Now, compared to when we studied this in Algebra 2, where we did an entire chapter on quadratic functions, we're pretty much going to do just one section of quadratics. So we did some prerequisites yesterday, and really it's kind of bleeds over pretty strongly into what we're going to do today. And so let's make sure we can do what we practiced on the last video, which is, can you put this into vertex form? The book will call this standard form, but I would say this is already in standard form because if you recall, this is a polynomial, and polynomials are considered to be in standard form when the degree goes from highest to lowest. So to call anything but this standard form is a little bit confusing. So again, when you're looking at the book and it talks about standard form, please understand it actually means vertex form. So let's get started. We're going to complete the square, which hopefully you all practiced and got very good at. And here we go. So I'm going to, I can leave it as f of x. I can write it as y equals. It doesn't really matter. When graphing, I feel more comfortable with y equals. And so I'm going to rewrite it. I'm going to scoot the 15 over a little bit. I'm going to take half of negative 2, which is negative 1, and I'm going to square it, which is plus 1. So I'm adding a plus 1, and I'm turning around and subtracting a 1. And so this part, and you don't have to put this in parentheses. I'm just doing this as a visual for you. I'm taking that chunk of this, and I'm factoring it into x minus 1 squared. Negative 15 minus 1, of course, is negative 16. And we have now put this into vertex form. All right, and now it's easy to graph. I'm going to go over 1 in the positive and down. I don't know why I chose such an ugly number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. And no scale change, so up 1, up 3 more, up 1, 2, 3, 4, 5 more, etc. All right. And our vertex is down here at, what is this, positive 1, negative 16. Okay, hopefully that went well. Let's move on. Example number 2. Show how to find the x-intercepts of f of x equals x squared minus 2x minus 15. All right, so we know the x-intercepts are simply when the y value is 0. In other words, we kind of want to find out when does this function, right, when does it intersect the graph of y equals 0, or when does it intersect y equals 0? Or really the best way to think about this is, again, when are the outputs equal to 0? So to answer this question, we have 3 typical methods that we'll use, and we'll review them all right here. So one would be to factor. So using factoring, we're making use of the fact that if you have two things multiplied together and they equal 0, a times b equals 0. The only way that is possible is if one of the factors equals 0 or the other equals 0, or I suppose both. So making use of that, we are going to try to factor this and then see if we can solve from there. So I'm going to rewrite this. I want to know when this thing equals 0. And so I will assume it factors. I'm looking for numbers that multiply to be 15 and subtract to be 2. That's going to be 5 and 3. I need it to be a negative 2, so negative 5 plus 3. And so just like we said above, a times b is 0. So either a, x minus 5 equals 0, or b, x plus 3 equals 0. And then I solve and I get x equals 5, or x equals negative 3. All right, so notice the question did specifically ask about x-intercepts, and x-intercepts are points. And so we really should not leave our answer right here. we should say, we could even get fancy with it if we want to, and I'm not requiring this. Therefore, like we did all this work, therefore, the x-intercepts are 5, 0 or negative 3, 0. Okay. So again, writing the therefore is not necessary, but I do want to see you translate it back into points. All right, solving from vertex form. So solving from vertex form, we would, if we hadn't already just done so, because if you'll notice, this is just the warm-up question we just did. If we hadn't already done so, we could use completing the square to arrive in vertex form. So vertex form, let's go grab it from above, is y equals x minus 1, the quantity squared, minus 16. So once again, I want to know when this equals 0, so I can just set it equal to 0. But this time, I don't have to factor. I don't have to do anything other than take a square root in a moment. So notice I just have one x term. By putting it into vertex form, I just now have one single x in the problem, where before I had two terms with x's in it. So I should be able to solve this simply by getting x by itself. So I'm going to add 16 to both sides, leaving me with x minus 1, the quantity squared. And then I'll take the square root. Since we're adding the square root, of course, we know that we need to include the positive and the negative. So I get positive or negative 4 equals x minus 1. I add 1 to both sides. I get 1 plus or minus 4 equals x. So x equals 5 or x equals negative 3, which again, since I was asking you not just what's the solution would be 5 or negative 3. I was asking for the intercepts, which are points, so then we would write them as points. And then there is our friend, the quadratic formula, which you probably have memorized, but I included it anyway. I'm not really going to talk about that right now. Let's just jump in and do it. In our case, I know that the A is equal to 1, and the B is negative 2, and C is negative 15. So x equals negative negative 2, so 2 plus or minus the square root of b squared. Since my b is negative, I don't really need to include the negative because it's squared, and I could just do 2 squared, but in case you're referencing these notes without watching the video, let me make sure to include the negative. Minus 4 times a is 1, c is negative 15. The number one mistake in using the quadratic formula, 2a is 2 times 1, is right here with the negative 4 and the negative 15, realizing that's a plus, and so we're adding the results of the squared and then the plus, what would be 60 over there. So just pay attention, make sure you don't make silly mistakes. Negative 2 squared is 4, minus negative and a negative makes a plus, so it'll be plus 60 over 2. So x equals 2 plus or minus the square root of 64 over 2. X equals 2 plus or minus 8 over 2. So x equals 10 over 2, or of course 5, or x equals 2 minus 8 is negative 6 over 2, which of course is the same answer we got before. So let's go look at our graph, because our graph would then be the fourth way we could solve these. I went over 1 up 1, up 3, up 5. The next one will be 7. 1, 2, 3, 4, 5, 6, 7, and 7. And so we can see that our graph crosses at 5, 0 and negative 3, 0. All right. We'll all have our favorite methods. And again, it may be somewhat equation dependent, but for me, I'm going to always make a quick glance and see if it factors quickly if I want the x-intercepts. If if that fails, then honestly, it's kind of depends on the numbers. And it's weird because I don't mind telling you, I do not like the quadratic formula. I think it's more cumbersome. Um, I don't like the fact that it's just kind of a plug and chug situation. I like the creativity of the um, completing the square method. But for some reason, once I leave the completing the square, like once we've practiced it, we move on to something else, I find myself not choosing to use it, even though I do find it superior. And honestly, I have no idea why. So I will always pretty much, at least if I'm thinking about it, I'll always go in this order. I'll try factoring, then I'll do solving using vertex form, and then last I'll use quadratic formula. Okay, so let's just practice this again on our own. So example number 3. Let's graph the function, and then let's find the intercepts and label the coordinates of vertex and intercepts on the graph. All right, so my hope here is anytime we're being asked to graph and it's vertex form, then it's a quadratic, then we need to put it in vertex form. So let's take a look at this one. So I'm going to write as y equals, just because I just feel more comfortable with that. And I'm going to notice that this negative is not where I want it. So I'm actually going to factor the negative out of just the first two terms. So that becomes x squared and plus 2x. And then we're just going to slide this plus 3 over here. I'm going to take half of 2, which is 1, and I'm going to square it, and I'm going to add it in. And then I would normally, and honestly, we're going to make this mistake, me included, if we don't stop and pay attention. So I know that I added 1, so normally I would now come out and subtract 1. But unfortunately, that is not correct. The actual answer is I need to add 1 here. Because, again, if we think about what did we really do, we added a 1, but this negative is being distributed through these parentheses. So this is really a minus 1. So the opposite of subtracting a 1 is to add a 1. So that's why we need to add 1. All right, so this factors, let me get back to black ink here. This factors into x plus 1 squared, and then those combine to be 4. So let's graph this, negative 1 and 4. 1, 2, 3, 4. All right, and I made a mistake, right? So I was about to graph this and have this big conversation with you and say, oh, look, it doesn't have an x-intercept. And then I was going to take you through and show you the math of why the math is failing us and not working. But that's all silly because I made a mistake. My mistake is I forgot to bring my little friend down here. All right, so now instead of going up, I'm going down. So down 1, down 3, down 1, down 3. And honestly, I've got the answer to the the intercepts graphically, and they're 100% accurate because they happen to fall on one of the integers. So I know the answer is 1, 0, and I know the answer is 1, 2, negative 3, 0. Let's pick one method of solving this that isn't graphing. So let's go ahead, since we've already done all this work, let's show this algebraically. You could factor, but why factor since we've already done all this work? Let's just solve it using the vertex form. So that means I'm just going to set what I just found equal to 0, because that's what I want to know. I'm going to subtract 4. I'm going to multiply by negative 1. I'll take the square root. I'm going to subtract 1. So I get negative 1 plus or minus 2 equals x. So I get x equals negative 3 or x equals 1, giving me intercepts of negative 3, 0, or 1, 0, which is what we got graphically. All right. Let's do one more, I think. I think that's all we have left. Correct. So this time I've just made it a little bit harder by throwing fractions in because we can't be scared of those. So please pause the video and try this on your own and check back in. All right, I am going to put it in vertex form. I'm going to save myself a little trouble. I'm going to factor out the half, giving me x squared plus 4 divided by half is 8, so that's 8x. And then I'm leaving the 8 out of that conversation and sliding it away. Half of 8 is 4, so I'm adding 4 down here and squaring it. So I'm adding a 16. And so then I'm going to subtract not 16. I'm going to subtract half of 16, which is negative 8. So I get 1/2 x plus 4 squared minus 16. And now we are in vertex form. I'm going to go ahead and find the x-intercepts right now. So once again, I'm going to just use the same method since I've already done this work. That's obviously when f of x equals 0. So I'm looking at 0 equals what I just found. Or you could go all the way back up to the original equation and then use factoring or quadratic formula, but I don't think you'll enjoy that very much. So we've done all the hard work. Let's keep going. So I get 16 equals 1/2 multiplied by 2. Take the square root, which is interesting, and subtract 4. So I get negative 4 plus or minus the square root of 32 equals x. All right, I'm going to clean up the 32. We're definitely going to simplify that. 32 is 16 times 2. And so then the square root of 16 is 4. So I get negative 4 plus or minus 4 square root of 2 equals x. Again, for those of us who need to see it, I'm just turning 32 into 16 times 2. Since they are factors, I can do them factor by factor, giving me the square root of 16 times the square root of 2, and the square root of 16, of course, is 4. So I get 4 square root of 2. Please don't be the kid that does negative 4 plus 4 and turns that into 0. Multiply comes before addition, so we cannot do that. These are multiplied together. So I have two choices here. I can leave this as it is, which I'm sort of inclined to do. I certainly would be inclined to do that if it was, hey, what's the x that makes this work? Then I would leave this answer because it's exact. But since I am graphing it, it does kind of make me feel like I should figure out what that decimal is. So I'm going to answer this kind of two ways here. I'm not saying you have to do this. You just need to be prepared to either leave it exact or go to a decimal if it asks for it. So I would say that my intercepts are simply negative 4 plus 4 square root of 2, comma 0, or negative 4 minus 4 square root of 2, comma 0, x, comma y. All right, so if I were to graph this, and I don't know why my examples are all way down at 16, but they are. Over to negative 4, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16. So I am here. Vertical scale change, up a half, up 3 halves, up 5 halves, 1, 2, 3, 4, 5, up 7 halves, 1, 2, 3, 4, 5, 6, 7. I'm going to keep going. 9 halves, which is what, 4 1/2? 1, 2, 3, 4.5, and then up 11 halves, which is up a half, and then 5 more. 1, 2, 3, 4, 5. All right. Normally, I would not obviously include this many points, but I just wanted to kind of see if my answer can be backed up by my graph. And so connecting these down, I see that I've got that point and I've got that point for intercepts. And so I'll grab my calculator and just estimate this. Square root of 2 is 1.41 and some change times 4. All right. And so I've got approximately 5.66. And so that's going to be what? Negative 9.660. Or let's see, what? 1.660. And if I go look at my graph, this one definitely could be approximately 1660. And 1, 2, 3, 4, 5, 6, 7, 8, 9, and some change. This definitely could be negative 9.660. Okay, I think that's it for this video. This was part 1. We got a little bit more to do in this section, but probably only about 10 minutes on the next video. All right, let me know if you need any help.